Introduction to Network Components. In this video, we are going to see about Introduction to Network Components. A computer network is any combination of computers and other devices that are connected by a central internet signal. The basic elements of a computer network are server. Server is a main computer that provides services to other computers which holds stored files, programs, and network operating system. This is the administrator that controls functioning of other computers and responsible for the division of labor among computers in a shared network. Clients. Any computer that is a part of a common network other than the server is called client. It is less powerful than server computer. The client computer accesses network and shared resources provided by the server. Network Interface Card, that is NIC. A NIC is also known as a network card. NIC connects a computer to the cabling, which in turn links all of the computers on the network together. Connecting devices. Hub. A hub is a device used to connect a PC to the network. The function of a hub is to direct information around the network, facilitating communication between all connected devices. Switch. However, in new installations, switches should be used instead of hubs as they are more effective and provide better performance. A switch is often termed as a smart hub. Modem. The first thing you need to start a network is a modem that is connected to an ISP, that is Internet Service Provider. A central internet connection is the foundation of a network. LAN Hardware. In this video, we are going to see about LAN hardware. The basic hardware components of LAN are transmission channel, network interface units, that is NIU, server. 4 types of channels are used for data communication in a LAN. They are twisted pair cable, coaxial cable, fiber optic cables, radio waves. Network interface units, that is NIU. A network interface unit is a device that provides interface for various other devices within a local area network, that is LAN. Server. LAN server is a program that serves the resources for a number of attached workstations. It is a dedicated system that controls one or more resources. 3 major categories of servers used in LANs are file server. It is used to share storage space for files, taking periodical backup, and provide gateway to other server within and between LANs. Printer server. It is used to handle printing works of all workstations connected in the network. Modem server. Modem is used to get connected to other network or use a telephone in LAN environment. LAN Operating Systems. In this video, we are going to see about LAN Operating Systems. LAN Operating Systems. LAN operating system is required to operate on the LAN system and manage a lot of workload with a number of various types of servers attached to it. LAN operating systems help sharing resources like printer, storage space, etc. Different types of LAN operating systems are Novel Netware, LAN Server, OmniNet, PCNet, IBM PC LAN, Etherlink Plus, etc. Introduction to Transmission Media. In this video, we are going to see about Introduction to Transmission Media. Transmission media interconnects the computers in a network. Transmission media may be wired or wireless, wired or bounded, coaxial cable, twisted pair wire, fiber optic cable, wireless or unbounded, Wi-Fi, Bluetooth. Resources: printers, scanners, fax device, and other network devices are the resources available to a client on the network. User is a client to access shared resources who is connected to that particular network. Protocols. The OSI Open Systems Interconnection Reference Model defines 7 layers of networking protocols. Protocol is a set of rules used for communication. These are the languages that computers use to communicate to each other on a network. Physical layer, data link layer. Data link and physical layers has Ethernet protocol. Network layer has IP, IPX protocols. Transport layer has TCP, SPX protocols. Application layer has HTTP, FTP, SMTP, DNS, Telnet protocols. Devices. The last step in creating a network is assembling the actual devices. The hardware can include desktop computers, laptops, notebooks, tablets, gaming systems, stereos, and even cell phones. Introduction to Guided Media. In this video, we are going to see about Introduction to Guided Media. Telecommunication links can broadly be classified into 2 categories, namely guided media, that is wired, and unguided media, that is wireless. Both media are used for short distance, that is LANs, MANs, and long distance, that is WANs communication. Electrical or optical signals are passed through a solid medium, that is different types of cables or wires. As the path traversed by the signals is guided by the size, shape, and length of the wire, this type of media is called guided media. Also in guided media, the signals are confined within the wire and do not propagate outside of the wire or media. For example, copper unshielded twisted pair, that is UTP, copper shielded twisted pair, that is STP, Copper coaxial cables, fiber optic cables. Twisted pair. In this video, we are going to see about twisted pair. A twisted pair cable is made of two plastic insulated copper wires twisted together to form a single media. Out of these two wires, only one carries actual signal and another is used for ground reference. The twists between wires are helpful in reducing noise, that is electromagnetic interference and crosstalk. There are two types of twisted pair cables. Shielded twisted pair, that is STP cable. Unshielded twisted pair, that is UTP cable. UTP is a set of twisted pairs of cable within a plastic sheet. UTP is ordinary telephone wire and it is the least expensive of all transmission media commonly used for LAN. There are 5 categories in UTP cables, in which Category 1, that is Cat 1, as the lowest quality, and Category 5, that is Cat 5, as the highest quality. Category 3 and Category 5 UTP are commonly used in computer networks, and the difference between them is the number of twists in the cable per unit distance. UTP can transfer data at 1 to 100 Mbps over a distance of 100 meters. This is the least expensive of all the transmission media commonly used for LAN and is easy to work with and simple to install. Category 3 and Category 5 UTPs are commonly used in computer network. UTP can transfer data at 1 to 100 Mbps over a distance of 100 meters. The standard connector for unshielded twisted pair cabling is an RJ45 connector. This is a plastic connector that looks like a large telephone style connector. A slot allows the RJ45 to be inserted only one way. RJ stands for registered jack, implying that the connector follows a standard borrowed from the telephone industry. Use of each category is as follows. Category 5 is used in local area network. It supports up to 100 Mbps transmission speed. Category 4 supports data transmission speed up to 16 Mbps and 3 twists per foot. Category 3 supports data transmission speed up to 10 Mbps and at least 3 twists per feet and used in telephone system. Category 2 supports data transmission speed up to 4 Mbps and suitable for voice data transmission. Category 1 is mostly used in telephone system. Cat 1 is suitable for voice and low-speed data communication. Characteristics of UTP cable. UTP has the following characteristics. Transmission rate of 10 to 100 Mbps. UTP is less expensive than FOC and coaxial cable. Maximum cable segment of UTP is 100 meters. UTP cable is very flexible and easy to work. UTP uses RJ45 connector. Most susceptible to electrical interference or crosstalk. Advantages of UTP cable. UTP is easy to terminate. Cost of installation is less. Disadvantages of UTP cable. It is very noisy. UTP suffers from interference. STP is a cable originally developed by IBM for token ring. They are not commonly used in networks. STP offers a protective sheathing around the copper wire. It consists of a foil or braid shield inside the outer jacket covering all wires. STP shielded twisted pair cable is a cable originally developed by IBM for token ring that consists of two individual wires wrapped in a foil shielding that helps to provide a more reliable data communication. STP shielded twisted pair offers a protective sheathing around the copper wire. Distance is limited from 100 meters to 500 meters. STP suffers from outside interference but not as much as UTP. Shielded twisted pair cable is available in 3 different configurations. Each pair of wires is individually shielded with foil. There is a foil or braid shield inside the jacket covering all wires. There is a shield around each individual pair as well as around the entire group of wires referred to as double shield twisted pair. Advantages: less susceptible to electrical interference caused by nearby equipment or wires. STP wire can carry data at a faster speed. Cheaper and far easier to install. It provides better performance at lower data rates. Disadvantages: STP wire is that it is physically larger and more expensive than twisted pair wire. STP is more difficult to connect to a terminating block. Coaxial cables. In this video, we are going to see about coaxial cables. Coaxial cable is made up of 2 conductors that share the common axis. It consists of a hollow outer cylindrical conductor that surrounds a single inner wire conductor. Coaxial cable is used to transmit both analog and digital signals, and its transfer rate is between TP and fiber optic cable. A typical data rate for today's coaxial network is 10 Mbps. Although potential is higher, it suffers from attenuation. Data transfer rate of coaxial cable is between TP and fiber optic cable. Following are some coaxial cable commonly used in networking. 50 ohm RG8 and RG11 for thick Ethernet. 50 ohms RG58 used for thin Ethernet. 75 ohms RG59 used for cable TV, 93 ohms RG62 used for ARC net. The two types of coaxial cabling are thin coaxial cable, thick coaxial cable. Thin coaxial cable. Thin coaxial cable is also referred to as thin net. The maximum segment length of thin coaxial cable is 185 meters. Thin coaxial cable has been popular in school networks, especially linear bus networks. 10(2) refers to the specification for thin coaxial cable carrying Ethernet signals. The 2 refers to the approximate maximum segment length being 200 meters. In actual fact, the maximum segment length is 185 meters. Thin coaxial cable has been popular in school networks, especially linear bus networks. Thick coaxial cable. Thick coaxial cable is also referred to as thick net. Thick coaxial cable has an extra protective plastic cover that helps to keep the moisture away from the center conductor. The maximum segment length of thick coaxial cable is 500 meters. Thick coaxial cable has an extra protective plastic cover that helps to keep the moisture away from the center conductor. This makes thick coaxial a great choice when running longer lengths in a linear bus network. Characteristics of coaxial cable: 10 Mbps is the transmission rate. Maximum cable length for thin net is 185 meters and for thick net is 500 meters. Flexible and easy to work with thin net. Ethernet designation to 10(2) that is thin net or 10(5) that is thick net. Less expensive than fiber optics cable, but more expensive than twisted pair. Good resistance to electrical interference. Applications of coaxial cable. Coaxial cable is used in analog and digital data transmission. A typical data rate for today's coaxial network is 10 Mbps. Although potential is higher, it suffers from attenuation. Coaxial cable is used in telephone networks. It is also used in Ethernet LANs. Advantages: it has higher bandwidth and easy to handle. It is used for longer distance at higher data rates. Excellent noise immunity. Disadvantages: distance is limited. Number of node connection is limited. Proper connectors and termination is must. Optical fiber. In this video, we are going to see about optical fiber. A fiber optic cable is a light pipe which is used to carry a light beam from one place to another. Light is an electromagnetic signal and can be modulated by information. The energy of light is produced to transmit data, which is used for long-distance telecommunication with high speed. A cable may contain a single fiber, but often fibers are bundled together in the center of the cable. Interior parts of optical fiber are jacket, buffer, cladding, and core. The inner core is surrounded by cladding, a layer of glass that reflects the light back into the core. At the destination, light rays get converted into signal again by using receiver. The modulated light travel along the fiber and at the far end are converted to an electrical signal by means of a photoelectric cell. Thus, the original input signal is recovered at a far end. The frequency of light is extremely high, hence it can accommodate wide bandwidth of information. Also, higher data rate can be achieved with excellent reliability. Advantages of fiber optic cable: wide bandwidth. The light wave occupies the frequency range between 2 into 10 power 12 Hz to 3.7 into 10 power 12 Hz. Thus, the information carrying capability of fiber optic cable is much higher. Low losses. Fiber optic cables offers less signal attenuation over long distances. Typically, it is less than 1 decibel per kilometer. Immune to crosstalk. Since fiber optic cables are non-conductors of electricity, hence they do not produce magnetic field. Thus, fiber optic cables are immune to crosstalk between cables caused by magnetic induction. Interference immune. Fiber optic cables are immune to conductive and radioactive interferences caused by electrical noise sources such as lightning, electric motors, fluorescent light. Lightweight. As fiber cables are made of silicon glass or plastic, which is much lighter than copper or aluminum cables. Lightweight fiber cables are cheaper to transport. Small size. The diameter of fiber is much smaller compared to other cables. Therefore, fiber cable is small in size, requires less storage space. More strength. Fiber cables are stronger and rugged, hence can support more weight. Long distance transmission. Because of less attenuation, transmission at a longer distance is possible. Disadvantages of fiber optic cable: high initial cost. The initial installation or setting up cost is very high compared to all other systems. Maintenance and repairing cost. The maintenance and repairing of fiber optic system is not only difficult but expensive also. Types of fiber optics. There are 3 varieties of optical fibers available. All 3 varieties are constructed of either glass or plastic or a combination of glass and plastic. The 3 varieties are plastic core and cladding, glass core with plastic cladding often called as PCS fiber, plastic clad silica. Glass core and glass cladding often called as SCS fiber, silica clad silica. Plastic core and cladding. Plastic fibers have several advantages over glass fibers. First, plastic fibers are more flexible and consequently more rugged than glass. They are easy to install, can better withstand stress, less expensive, and weigh approximately 60% less than glass. The disadvantages of plastic fibers are their high attenuation characteristic. They do not propagate light as efficiently as glass. Consequently, plastic fibers are limited to relatively short runs, such as within a single building or a building complex. Glass core with plastic cladding. Fibers with glass cores exhibit low attenuation characteristics. However, PCS, plastic clad silica fibers, are slightly better than SCS, that is silica clad silica fibers. Also, PCS fibers are less affected by radiation and are therefore more attractive to military applications. Glass core and glass cladding. SCS fiber has the best propagation characteristics and they are easy to terminate than PCS fibers. Unfortunately, SCS cables are the least rugged and they are more susceptible to increase in attenuation when exposed to radiation. The selection of a fiber for a given application is a function of specific system requirements. There are always trade-offs based on the economics and logistics of a particular application. Mode of fiber. Fiber cables can also be classified as per their mode. Light rays propagation as an electromagnetic wave along the fiber. The two components, the electric field and the magnetic field, form patterns across a fiber. These patterns are called as modes of transmission. The mode of a fiber refers to the number of paths for the light rays within the cable. According to modes, optic fibers can be classified into two types. Types of fiber optic cable: single mode fiber, multi-mode fiber, step index, graded index. Single mode fiber. In single mode, fiber has a center hole that is sufficiently small so that there is essentially only one path for light ray to pass through the cable. The light ray is propagated in the fiber through reflections. It allows propagation of light ray by only one path, and multimode fiber allows multiple paths for light ray to propagate. The number of modes n is given by the formula n is equal to 1 by 2 pi d by lambda into the square root of n1 square minus n2 square, where d is the diameter of core, n is the numerical aperture, lambda is the wavelength of light ray. Multimode fiber. In multimode, light waves are dispersed into numerous paths or modes as they travel through the cable's core. Step index. Step index multimode fiber has a large core where some of the light rays that make up the digital pulse may travel a direct route, whereas others zigzag as they bounce off the cladding. It is easy to manufacture. Its core diameter is 50 to 1000 micrometer, that is large aperture, and allows more light to enter the cable. Graded index. Graded index multimode fiber contains a core in which the refractive index diminishes gradually from the center axis out towards the cladding. The light ray is propagated through the refraction. This cable is mostly used for long-distance communication. Characteristics of fiber optic cable. Fiber optic cable has the following characteristics. Transmission rate of 100 Mbps, not affected by the electrical interference, most expensive cable. FOC support cable length of 2 km or more. Application of fiber optic cable. It is used for long-distance transmission across ocean. Due to low rate of bit error and noise-free transmission, optical fiber is used for long-distance transmission across ocean. Used for broadband internet services because it is lasts longer than copper cables. Fiber optic cables are expensive to install but last longer than copper cables, and so it is used for broadband internet services. Introduction to Unguided Media. In this video, we are going to see about Introduction to Unguided Media. Introduction to Unguided Media. The information is transmitted by sending electromagnetic signals through free space, and hence the name Unguided Media, as the signals are not guided in any specific direction or inside any specific medium. Wireless transmission can be used as a medium in both LAN and WAN environments, as illustrated. Wi-Fi, WiMAX, 3G are examples of wireless networks used for internet communication. Radio. In this video, we are going to see about radio. Radio waves generally are utilized by antennas of appropriate size according to the principle of resonance, with wavelengths ranging from hundreds of meters to about 1 millimeter. They are used for transmission of data via modulation. Television, mobile phones, wireless networking, and amateur radio all use radio waves. The use of the radio spectrum is regulated by many governments through frequency allocation. Radio waves can be made to carry information by varying a combination of the amplitude, frequency, and phase of the wave within a frequency band. When EM radiation impinges upon a conductor, it couples to the conductor, travels along it, and induces an electric current on the surface of that conductor by exciting the electrons of the conducting material. This effect, the skin effect, is used in antennas. Very high frequency, that is VHF. In this video, we are going to see about very high frequency, that is VHF. Very high frequency, that is VHF, is the ITU designation for the range of radio frequency electromagnetic waves, that is radio waves, from 30 MHz to 300 MHz with corresponding wavelengths of 1 to 10 meters. Frequencies immediately below VHF are denoted high frequency, that is HF, and the next higher frequencies are known as ultra high frequency, that is UHF. Common uses for VHF are FM radio broadcasting, television broadcasting, two-way LAN mobile radio systems, long-range data communication up to several tens of kilometers with radio modems, amateur radio, and marine communications. Antennas. VHF is the first band at which wavelengths are small enough to make efficient transmitting antennas for vehicles and handheld devices. So, the VHF and UHF wavelengths are used for two-way radios in vehicles, aircraft, and handheld transceivers and walkie-talkies. Portable radios usually use whips or rubber ducky antennas, while base stations usually use large fiberglass whips or collinear arrays of vertical dipoles. Microwave. In this video, we are going to see about microwave. The super high frequency SHF and extremely high frequency EHF of microwaves are on the short side of radio waves. Microwaves are waves that are typically short enough, measured in millimeters, to employ tubular metal waveguides of reasonable diameter. In a mobile phone, they are made by a transmitter chip and an antenna. In a microwave oven, they are made by a magnetron. Microwave oven. This effect is used to heat food. Low intensity microwave radiation is used in Wi-Fi, although this is at intensity levels unable to cause thermal heating. Stars also give off microwaves. Microwave generators are commonly used in industry to cure chemical reactions, heat a part, or seal a plastic seam. This form of radiation is normally transmitted into the atmosphere from antennas like television antennas, FM radio antennas, and radar transmitters. Microwaves are also used by fixed traffic speed cameras and for radar, which is used by aircraft, ships, and weather forecasters. Satellite. In this video, we are going to see about satellite. A communication satellite is in effect a microwave relay station. It is used to link two or more ground-based microwave transmitter or receivers known as earth stations or ground stations. The satellite receives transmissions on one frequency band, that is uplink, amplifies or repeats the signal, and transmits it on another frequency, that is downlink. A single orbiting satellite will operate on a number of frequency bands called transponder channels or simply transponders. The optimum frequency range for satellite transmission is in the range of 1 to 10 GHz. Most satellites providing point-to-point service today use a frequency bandwidth in the range of 5.925 to 6.425 GHz for transmission from Earth to satellite, that is uplink, and a bandwidth in the range of 3.7 to 4.2 GHz for transmission from satellite to Earth, that is downlink. This combination is referred to as the 4x6 GHz bands, but has become saturated. So the 12x14 GHz bands has been developed Uplink 14 to 14.5 GHz, downlink 11.7 to 12.2 GHz. For a communication satellite to function effectively, it is generally required that it remain stationary with respect to its position over the Earth to be within the line of sight of its Earth stations at all times. To remain stationary, the satellite must have a period of rotation equal to the Earth's period of rotation, which occurs at a height of 35,863 kilometers at the equator. Two satellites using the same frequency band, if close enough together, will interfere with each other. To avoid this, current standards require a 4-degree spacing in the 4x6 GHz band and a 3-degree spacing at 12x14 GHz band. Thus, the number of possible satellites is quite limited. Among the most important applications for satellites are television distribution, long-distance telephone transmission, private business networks, and global positioning. Infrared. In this video, we are going to see about infrared. The infrared part of the electromagnetic spectrum covers the range from roughly 300 GHz 1 mm to 400 THz 750 nanometer. It can be divided into 3 parts. Far infrared from 300 GHz 1 mm to 30 THz 10 micrometer. The lower part of this range may also be called microwaves. This radiation is typically absorbed by so-called rotational modes in gas phase molecules, by molecular motions in liquids, and by phonons in solids. The water in Earth's atmosphere absorbs so strongly in this range that it renders the atmosphere in effect opaque. However, there are certain wavelength ranges, windows, within the opaque region that allow partial transmission and can be used for astronomy. The wavelength range from approximately 200 micrometer up to a few millimeters, often referred to as sub-millimeter in astronomy, reserving far infrared for wavelengths below 200 micrometer. Mid-infrared from 30 to 120 terahertz, that is 10 to 2.5 micrometer. Hot objects, that is black body radiators, can radiate strongly in this range, and human skin at normal body temperature radiates strongly at the lower end of this region. This radiation is absorbed by molecular vibrations, where the different atoms in a molecule vibrate around their equilibrium positions. This range is sometimes called the fingerprint region, since the mid-infrared absorption spectrum of a compound is very specific for that compound. Source channel detector. In this video, we are going to see about source channel detector. Any fiber optic data transmission system will comprise a number of different elements. There are 3 major elements and a further one that is vital for practical systems. Source, that is transmitter. Channel detector, that is receiver. Source, that is transmitter. Although the original telecommunications fiber optic systems would have used large lasers, today a variety of semiconductor devices can be used. The most commonly used devices are light-emitting diodes, that is LEDs, and semiconductor laser diodes. The simplest transmitted device is the LED. The main advantage is that it is cheap, and this makes it ideal for low-cost applications where only short runs are needed. However, they have a number of drawbacks. The first is that they offer a very low level of efficiency. The other disadvantage of LEDs is that they produce what is termed incoherent light that covers a relatively wide spectrum. Channel detector, that is receiver. Light traveling along a fiber optic cable needs to be converted into an electrical signal so that it can be processed and the data that is carried can be extracted. The component that is at the heart of the receiver is a photodetector. Once the optical signal from the fiber optic cable has been applied to the photodetector and converted into an electrical format, it can be processed to recover the data, which can then be passed to its final destination.